Okay, so I'm going to start off with what is going to actually be on the test because it is a huge chapter and I want to go through each piece, okay? So let's start with 3.1 and 3.2. 3.1 was the basics of derivatives, like that long form stuff, like the limit as h approaches 0. There's no need to do that again. We all know the shortcuts already, so we're not going to do that section. So 3.1 is not relevant. 3.2 is talking about derivative differentiability, whether it is or isn't derivative. We're also not going to do that. So 3.1 and 3.2 not going to be on the test. Now, 3.3. 3.3 is the general rules like the power rule, sum addition rule, product rule, those kind of very simple rules that are relatively easy compared to all the other ones. And there's a couple of problems that we're going to do from it. Not only are you going to get like a polynomial, like x to the third plus 2x to the second plus 1x to the 1 minus 5, something like that, derive that. You're going to have also one where I'm going to ask you to plug in f prime of some number. So if I say, give me f of prime of 2, you're going to derive it. Then with that new derivative function you have, you're going to plug in the number 2 into it. And you have to solve, and every x you see, you got to plug in the 2 into it, and you have to solve it. So if I'm asking for a derivative at a point, or if I ask you f prime of 2, that means I want the derivative where x equals 1 or 2 or whatever it is, okay? There's another question from this section that we haven't done in a long time, so I'm going to do one on the screen here. It is tell me what the tangent line is. Close. Oh, never mind. So tell me what the tangent line is. So what does that involve? I'm going to give you like a very basic question. It will be a polynomial function for this question, but it's pretty straightforward. So let's say it is, let me do 3x squared plus 6x minus 1 equals, let's say, f of x. Now the question could be, please give me what is the equation for the tangent line. The equation for the tangent line where x equals, let's put 2 here, okay? So in order to make an equation of a straight line, and tangent lines are always straight lines, you need two things. Either the slope in the y-intercept or the slope in a point, because you could do it in y or slope-intercept form or point-slope form. Now, it's easier to find a point, so we're going to purposely use point-slope form. If you don't remember what point-slope form is, it is y minus y1 equals m x minus x1. We're purposely picking point-slope form. So all we need to look for is the point and the slope. Well, for the point, you just need to plug it in. So I'm going to find what f of 2 is. So 3 times 2 squared plus 6 times 2 minus 1. 2 squared is 4. 4 times 3 is 12. Plus 6 times 2 is 12. Minus 1. 24 minus 1, 23. So f of 2 equals 23, which, by the way, is your y. So you know at this curve, whatever it looks like a parabola, but whatever parabola will look like here, you know there's a point where it's on 2, 23, the line. So now we need the slope, but luckily for us, we have a way to find a slope at any given point, at any given function, and that's the derivative. So what we're going to have to do is f prime this function. So we're going to need the f prime of this, and I'll do it in different colors so it's clear. So we need the f prime of this function, which is going to be 6x plus 6, and then the 1 gets canceled out because it's a constant. But not only we need the function, but we need the actual slope at that point. So now we're going to plug in f prime of 2. Prime of 2. So that's 6 times 2 plus 6, 12 plus 6, 18. 18 is the derivative at f equals 2, or also in this case, your slope of the tangent line. Your final piece of the question here is just simply put it all together in one equation. Y minus, we have our y value, which is 23, equals 18, x minus 2. You could make it in y equals mx plus b form. That's a waste of time. Just leave it like that. We're happy. So you're going to get a question like that. And we haven't done it in a long time, and definitely I wanted to go over something like that. Either guys on Zoom, you have any questions on that?
Do we have to do the thing where we make the m like the reciprocal?
That would be if I asked for the normal line. I'll tell you right now, I'm not going to ask for the normal line.
Okay, thanks.
That's just the tangent line, yeah.
So just the tangent line and then the normal rules for this chapter, for this section.
Yes, for 3.3. So
Got it.
You'll get a basic polynomial one. So like something like f of x right here. You're going to get one where I'm going to ask you, hey, give me the f prime of 2. So you have to prime it and then plug in 2. And then you're going to get one where it involves the tangent line. And you can see how it gets more involved each time.
Okay, thank you.
No problem. All right. Let's go to the next section, 3.4, which is strangely the last section we did. But 3.4 is those physics problems. At least that's the one we practiced. Well, I didn't feel like we had time to practice anymore because we lost that Thursday and that Wednesday. So, but it's going to be basically either a rock is being thrown into air or a ball's bouncing really high, something along those lines. You have your basic situations you should be aware of. Jay, you still writing this down, or you want me to go to the? Can I go to the next page? Okay. So you have your basic situations. Here's some situations that you might need to know. For example, if I ask you when the rock hits the ground, if the rock hitting the ground, that means your position. Remember, we use S for position. Should equal 0. And I guess before I even talk about more questions like that, S is your position or your placement or your height, whatever you want to think of it. V, which is S prime, is your velocity. And A, which is the prime of V, which is the double prime of S, is your acceleration. So something like rock hitting the ground, that should be when S is 0. But no, you're going to have two S's zeros. One is the first time you threw it. So you're starting, so you got to take your second one. If I say rock at the highest point, that means it's going to be when the velocity is 0, because at that point, there's a point of suspension, and then it falls back down. So you want to figure out what the velocity is 0. Now be careful. I might ask, what time is the rock at the highest point? So you will make the velocity equation equal 0 and find t. And once you do that, you're good. But if I ask you what height it is at the highest point, then you have to not only find t, take that t and plug it into s. So you got to make sure you follow through depending on the instructions. Let's see, is there anything else? Highest at the peak. I could ask, what's the speed or the velocity at a rock at some specific height? So for example, like 100 feet, let's say. So if you do have something like that, you want to put S equals 100. And then that'll get you t, and then with that t, you get your velocity or your acceleration, or depending on what I ask you, follow through. Like, what's the acceleration of the rock as it's 100 feet going up? And remember, if it's going up versus going down, going up is going to be your first one that occurs, so your smaller t, and your going down should be the the reverse. So what am I thinking of? Whatever, the second t that occurs. Okay. And I'm happy to do a problem after I go over the general stuff. What's up, Jay?
You over an equation for this?
Is there an equation for this?
Can you go
No,
over
because I
like
have
do you have like a problem for like an example for these?
I could use a problem from the practice sheet. Yeah, let me open that up actually. No.
Is the equation always going to be different, like just depending on what the question you gives us? There's no
Yeah, so you
standard.
have to be. It's always going to be a polynomial. I'll tell you that. Like it'll
Like
just
the
be
equation's always going to be like depending on whatever question. It's not like there's one equation for this kind of question.
Yeah, your SV and acceleration is always going to be the based off whatever I tell you. So if S is x squared or whatever, you have to base it off that. How very simple is that? Okay, wait a second. All right, so let me open up the Google Classroom. I'm going to open up the review question that was there. Oh wait, wrong child class. Where is it? Or 70. Oh, 70. Okay. So we'll use the free fall. So this is number 72 on the review. This is more accurate to what you're going to do. So 72 on the review. Free fall. Suppose two balls are falling from rest at a certain height in centimeters above the ground. Use the equation S equals 490 t squared for the following equations. Okay. How long does it take the ball to fall the first 160 centimeters? What is the average velocity for that period? Okay, so there's two questions in there actually. First, how long does it take for the ball to first fall 160 centimeters? So, just want to make sure. All right. So, part A, how long does it take to fall 160 centimeters? So I want the S to be 160. So 160 equals 490 t squared. Divide 490 on both sides. 160 over 490. I can simplify that by taking away the zeros. So that's 16 over 49 equals t squared. T squared. Square root both sides. 4 over 7 equals t. So there's a plus or minus technically, but you should keep in mind you can't really have a negative time. So it should just be a positive time.
Where did you get 160?
From the question, it says, how long does it,
Okay.
it says, yeah, how long does it take for the first 160? So that's what it is. Okay. So it takes 4 out of 7 seconds, or 4/7 of a second to get to 160 centimeters. Now, the second part says, what is the average velocity? So to find the average velocity, if it was a physics problem, you would think of it as your initial or your final minus your initial over your final time minus your initial time. In mathematics, we write it like your S of your final time, we'll call that, I guess we could call that T sub 2, minus your initial time, T sub 1, over your final time minus your initial time. So our final time is S over 4/7. So you would plug in 4/7 into this equation. But we already know what 4/7 is in this equation. They give us in the beginning, 160. Minus S at initial. Now, if your initial is 0, if we plugged in 0 into this equation, we would get 0 over 4/7 minus 0. So this is going to simplify into, on the top, this becomes a 160 because we know 4/7, and if you don't trust yourself, you could plug it back in. 4/7 squared times 490 will give you 160. Minus S of 0, which is 0, because it wasn't anywhere at the beginning, over 4/7 minus 0 is just 4/7. So 160 over 4/7. I would rewrite that as 160 divided by 1 times the reciprocal of this, which is 7/4. That's 1. That's 40. So 40 times 7 is 280. So 280, it would be meters or centimeters? Centimeters per second.
Can you repeat what you did from like how you got the how you replaced the 4/7 with 160?
Oh, we just figured out that when it equals 160, the time is 4/7. So if I know the time is 4/7, then the distance should be 160. If you're not sure, you could take 4/7 and just plug it in here. So 490 times 4/7 squared. That's 490 equals, or times, I'm sorry, times 4 squared, which is 16, over 7 squared, which is 49. You could simplify this to 1, and you could simplify this to 10. And then 10 times 16 would get you 160. So you could always just plug it back in. But you already knew that because I gave you 160. You found the time. So there's no reason to redo the time to find the 160 again. So I'm just pointing that out as a time saver. Okay. Any other questions?
I have a question.
Go ahead, Brianna.
Well, I have 2 questions. One, remember on Friday you were talking about how we might have to plug some of the answers into like the original equations?
Yeah.
What section would that be that we have to do that?
That would be in section 3.3. And you kind of missed it because I did it earlier.
Oh,
But
okay.
I
know all of them. I just want to know like which one is 3.3?
3.3 was the general power rules, like power rule, sum rule, product rule.
Yeah.
So they're the basic rules. And then also we had situations where I ask you find the tangent line, the equation of the tangent line. That's a question you'll have on your test. And then find the derivative at this exact point. So you would find the derivative first and then plug in the point.
Find the derivative first and then plug that derivative into the equation.
Yes.
Okay.
Okay.
And the tangent
It'll say something
line,
like, I just want to be clear. It'll say something like find f prime of 3. So you find f of prime first and then plug in 3.
got it. Okay. And then my other question is, remember for the other quizzes, we just had to know like sine, cosine, and tan?
Yeah, keep it to sine, cosine, tan.
Okay. Thank you.
No problem. All right, so I'm going to go back to the textbook. I'm going to just keep scrolling down for myself. Talk about what's on each section. Okay, so 3.5 is a trig function. It'll basically also be a chain rule question. So something like, let me pick a different one. Let's say cosecant. Cosecant of 3x to the 5th, something like that.
What chapter is this part of? What section?
This would be 3.5 trig stuff. Now, in your textbook, it would be in both 3.5 and 3.6 trig stuff because they only talk about chain rule in 3.6. So you're going to get very basic tangent problems or trigonometry problems in 3.5, and then you get the more relevant ones in 3.6. But here's a basic tangent one. Or I keep saying tangent, trigonometry one. Okay, so we have cosecant 3x to the fifth. Anyone here remember what the derivative of cosecant is?
It's negative cosecant cotangent.
Good. So remember, and so the general formula for it is whatever your trig function of the u is going to be the trig derivative of it. So whatever the derivative of it, with the u being exactly intact, so the trig prime of it, times the derivative of the inside, u prime. So cosecant is negative cosecant cotangent x. So it's going to be negative cosecant. This is going to stay intact, 3x to the fifth, times cotangent, I believe, cotangent, 3x to the fifth, times the derivative of the inside. So the derivative of the inside, which is 3x to the fifth, bring the 5 down, 15x, reduce the power by 1 to the fourth. Okay. If you rewrite it with 15x to the fourth in front, that's okay. Since it's a large test, I'm not going to rush you or give you on formatting. What's up, Brianna?
I have a question. Can you just write it as like negative cosecant x cotangent x of 3x to the fifth times the derivative of the inside? Like, do you have to separate?
No, it's cosecant. That's a good question. It's cosecant 3x to the fifth, cotangent 3x to the fifth. It's not cosecant cotangent.
Okay.
Because that would imply that the cotangent is within the cosecant, which is not correct. Okay.
Do you only put the negative on the cosecant?
It's a negative in front of the whole expression. So unless there's two negatives that cancel out, the negative could be wherever. Like if it was like 3x to the negative fifth, you would bring down -5 and then negatives would cancel out. That I would like you to do, cancel out the negatives. But otherwise, it's fine.
In this section in 3.6, when's the exact time that we need to use the chain rule?
What? What's the exact time?
I didn't make that clear. Like last night I was going over some of the problems. I was trying to figure out when I need to use the chain rule and when's the end of the when's the end of this problem.
Oh.
So like in this, like do we just stop there, or like sometimes this is to take the 3x to the fifth and just keep going one more to make
Yeah,
15x
you
to the fourth?
basically. So Jay, basically, when in doubt, always do the chain rule. So I'm going to do one where it's just sine of x, where the chain rule is not necessary, but you'll see what will happen. If I did the chain rule because I'm nervous on the test, I don't know what's happening. The derivative of sine is cosine of x times the derivative of the inside. Now, what's the derivative of x? It's simply 1. And then you wouldn't need to write that because it's just times 1. So your answer is just simply cosine x. So there's a situation where chain rule was not necessary, but if you do it, you're not going to get it wrong because you're just priming just an x power or just a single term. So when in doubt, chain rule. But if it's just x, you usually don't have to continue chaining rule. But usually when it's something within something else, you have to chain rule. Okay. I don't think I mentioned this, but 3.3 also have the product and quotient rules when I said the basic rules. So 3.3 has the product and quotient rule, which I shouldn't have said is basic. It's not so basic, but it's one of those earlier rules. Okay.
Mr.
All right.
Tobal, if there's time at the end, I have a question.
Sure.
If there's time at the end, can you just go over one time what you mean about like the tangent line?
Sure. I'll go over it then. Okay. So 3.6 was chain rule stuff. Now, chain rule could have multiple ways to chain rule. So you could have some I would say basic chain rule like this: 3x to the 5th plus 5x to the 2nd to the 7th power. And chain rule works as the function within the function. So the prime of the function on the outside with the function on the inside being exactly the same times the prime of the inside function. This one, I don't know how to write it with u's and v's, so I have to write it like this. So the prime of the outside with the inside intact times the prime of the inside. So in this case, the prime of the outside. So it's kind of like a u to the 7th power if you want to think of it like that. So if you had u to the 7th power, you would bring down the 7th power. U would stay intact, which is 3x to the 5th plus 5x to the 2nd. And then you would reduce the power by 1. So 6. Multiplied by the u prime of this, or whatever the inside prime is. So this would be 15x to the 4th, and I have to put parentheses, 15x to the 4th plus 10x. From there, there's no really need to distribute or anything. I'll just leave it like that. Again, I'm not going to concern about formatting. We don't have enough time. Or it's not fair. It's already a big test. I'm not going to format too much. Okay. Now, let's say a more complicated chain rule. So let's say with a trig inside. So let's say, no, I want to use one that has 2 terms. We'll use cosecant again. So cosecant to the 4th power, 3x to the 5th. Yeah, okay. So this one, Jay, this might be one of those questions that you meant, like, when do we stop chain ruling? It's hard to answer that question, so I'm going to say you just keep going until there's like nothing left to chain. So remember cosecant to the 4th power, you could also kind of look at it as cosecant 3x to the 5th, all to that to the 4th power. So this is actually a bigger chain rule where it's u to the 4th first. So I'm going to bring down the 4th power, which is 4. U is going to stay the same, cosecant. It's going to get reduced by a power, which is 3, times the inside, which is exactly the same, 3x to the 5th. Or the inside has stayed the same. The inside in this case is cosecant 3, 5 to the x. Now I need to multiply it by its u prime. The u prime, or the u, is cosecant 3x 5th. So I have to multiply it by the derivative of cosecant 3x 5th, which is negative cosecant 3x to the 5th times tangent, or not tangent, cotangent 3x to the 5th. But you can't forget this derivative is technically also a chain rule. So we need the chain of that. And then we need the derivative of the inside, which is 15x to the 4th. Basically, you're doing 3 layers of chain, or 2 layers of chain rule. The first layer is for the 4th power. The second layer is for the cosecant. And then your final derivative that's occurring is the 3x to the 5th. So your first layer is the 4th power. Your second layer is the cosecant stuff. And then your last layer is the inside polynomial.
2 questions. One, if we write the 15x to the 4th on the outside, is that a problem?
Of the parentheses?
Yeah.
No, that's not a problem.
Okay, and second, can you explain like the rule of if you have like cosecant to the fourth, then the 3x to the fifth, and then you're allowed to kind of merge them together? Can you explain that a little bit?
Say that one more time. If I have the what?
You change the cosecant to the fourth, 3x to the fifth, into cosecant 3x to the fifth to the fourth. Can you
Huh.
explain that rule? And if we can use that rule like multiple times?
Sure. So if it's a trig to the function, like a power like this, that's the same thing as saying cosecant 3x to the fifth all to the fourth power. These are equivalent statements right here and here. These are equivalent statements. The reason why I would redraw it to the bottom is just to make it more clear. We have a power rule, which is going in green, and we have a trig rule that's kind of separate. And I just wanted to make that very clear for us. So you could always rewrite it.
And how do you recommend we use like this this tactic and try not to confuse it with other problems on the test?
When you have a trig rule, like the previous page, I think. Oh, we did the same exact one. I'm not creative. But if you have a trig rule where there's no power, then you could just do your basic trig rule. But as soon as you see a power, some kind of influence to it, then you have to keep that in mind. Oh, there's something more going on. So that's when you got to pay attention. Did I really pick the same numbers? Jeez. All right. Okay. So those are some examples of chain rule. 3.6. 3.7, implicit differentiation. Implicit differentiation. So this one is a little unique because it's not like a hard rule. It's more like a different style of question. So here's a very basic one. Y squared equals 5x squared plus 10x minus 1, something like that. So this one, and you'll know it's a different question because I'll be saying find the dy of dx versus usually I say find f prime. So you got to do implicit differentiation. Typically why this occurs is just because y has some operation occurring to it. There's something occurring to y. Usually it's f of x equals blank or y equals blank. So your y is usually by itself and has nothing happening to it. These questions, why something is happening to it, is being multiplied, is being primed, something along those lines. The reason we can't square root it first at both sides, first off, we don't know what the square root of that polynomial is. But second off, that would include the plus and the minus. And because it includes the plus and the minus, it stops being a what we would call a one-to-one function. So we can't allow ourselves to do that. So we're going to have to use implicit differentiation. So how do we do it? Y's prime, well, x prime is just simply 1. Y prime is dy dx. So we have to consider it slightly different than x prime. So when I do this here on the left, it is a chain rule where the top is 2. For example, if it's a chain rule, it's 2 times the original, which is y, times the derivative of the inside. The inside in this case is just simply y. And the derivative of y is just simply dy dx. Equals, I have to prime this side. So that's 10x plus 10. My job is to get y by itself. So I'm going to divide, or dy dx by itself, I'm sorry. So I'm going to divide 2y on both sides. Dy dx equals 10x plus 10 over 2y. And that would be your answer right there. You could technically simplify the 2's and take everything 2 out. I won't mind that. Along with that, I want to give another type of problem that's also differentiation, implicit differentiation. Let's say something like x squared times y squared equals 10, something like that. Now, if I remember when we had the quiz, a common error was you just prime this and times it by the prime of that. But what's occurring here is actually a product rule, where it's u times v. U in this case is x squared, and v in this case is y squared. So you got to be wary for that. This is not a simple, oh, I just bring it down like it's a constant times a number. No, this is where you have to actually do a product rule. So the derivative of u is 2x. So u prime is 2x. The derivative of v is v prime, which is 2y dy dx. So if you don't remember the chain rule or product rule, u v prime plus v u prime. So u x squared times v prime 2y dy dx plus v, which is y squared, u prime 2x, equaling the prime of this, which is simply 0. Remember, my ultimate goal is to get y dy dx by itself. Almost said y prime, dy dx by itself. So since this is being multiplied to dy and this is being added dy, I move it in reverse PEMDAS. So I'm going to move the addition first. So I'm going to subtract both sides by 2xy squared. I'm just rearranging it. That's okay. So over here, I have 2yx squared dy dx equals negative 2xy squared. Now I need dy dx by itself. This is being multiplied by dy dx. So I'm going to divide dy dx on both sides. Or I'm not dividing dy dx. I'm dividing everything next to dy dx. 2 yx squared. So dy over dx should equal, in this case, negative 2xy squared over 2x squared y. And I can simplify that a bit to negative y over x. That one's very simple to simplify. I think we should do that. Because the 2's cancel out, one x cancel out, one y cancel out. Should be pretty simple to simplify. Something where it's just rearranging. Yeah. Something like this is good to simplify. So the key part here is remember y is not the same as x. You can't just do x squared is 2x. Y, every time you derive y, you're going to have a deal with a dy dx out of it. Okay? Does anyone have any questions on that? Okay, so that was 3.7, implicit differentiation.
Actually, I have one just to clarify something.
Yeah.
I don't know why I'm confused about this, but when you do the chain rule, when you use the y squared, you make it 2y. Why? Can you repeat why you multiply by dy dx?
Y is the dy dx is multiplied by 2y. Is that your question?
Y is the 2. No, because the chain rule is you put one over and then you subtract 1. So I understand why you have 2y. I'm just kind of confused why you multiply by dy dx.
Oh, so technically, let me some space, I guess. I'll just put a new page. Technically, I'll use y third as a different number, so be a little bit more clear, right? So y third, kind of the same situation as u to the third, where you would have the power rule, 3u to the second power times u prime, okay? Now, for y, that will be 3y to the second power times the derivative of y. This is why it's implicit differentiation. The derivative of y is not 1 in the way that derivative of x is. Derivative of y is dy dx. So the derivative of y is dy dx. If I were to do this with x to the third, what would occur? Well, 3x to the second times the derivative of just x, which is 1. So that's why in this one, you don't have to really do the chain rule. While on the left with the y, I do have to do the chain rule because the derivative of y is dy dx. As a special note, as a special note, the derivative of x is technically dx over dx because you're deriving it based off x, but since it's the same thing on top and bottom, you can reduce that to 1. And that's been true the whole time. It only pops up to be relevant here. I kind of mentioned when I was teaching it, it's not really a fact you need to know, but that's the basics of it. It's dx technically over dx. Technically, all our derivatives have been above dx.
Oh, thank you.
No problem. Okay. Let's go to 3.8, inverse of trig functions. 3.8 and 3.9 is basically a memory test. Do you remember the rule for whatever situation? That's basically it. So let's do one. Let's see. Let's do a cosine one. No, let's do a sine one. Let's just keep it basic. All right. So let's do sine of -1. I don't know why I always use these numbers. 3x to the 5th. So you need to remember your derivative of this. Not a 4, that's a u. So sine of u, -1u, is going to be u prime over the square root of 1 plus u squared. Gosh, I hope I remember that correctly.
Yeah, that's right.
Thank you. All right. So u prime over 1, the square root of 1 plus u squared. So just identify yourself what the u is before you start. If u is 3x to the 5th, u prime is 15x to the 4th. That just helps you out. Make sure you're cleaned up. Okay, so up here, 15x to the 4th over the square root of 1 plus 3x to the 5th, all of that squared. So you actually want to do the square of that, which is the square root of 1 plus, this is going to be 9x to the 10th. Remember, you square normal numbers, while exponent rules say you just multiply when you do power to power. Okay, and that's it. Again, the inverse trig and along with the log and exponential is just a memory test in this situation. You just need to know the formula. There's not much simplification or tricks you can do with it, other than make it really complicated, but that's not for this test. I would say just make sure you know the first 3. That's the most important 3. So sine, cosine, tangent, I should say. The original 3, the original trig functions. Anyone has any questions?
No.
Okay. Cool. Let's go to last section, 3.9. 3.9, I think is log and exponentials. Yep. Log and exponentials. Just to go over the rules again. some a to the u power is a to the u power times ln a times u prime. Now, when it comes to e to the u power, what's really nice about e is that ln of e cancels out. So e to the u power is just e to the u times u prime, because ln e cancel out. And then we have log base a of u. So that is a u prime over ln a times u. Yeah, times u. Okay. And and then ln, what's special about ln is that since ln is the same as log e, and ln of e is reduced to 1, you just have to do u prime over u. Okay. So the questions, again, this is more a memory test than anything. In terms of what is required of you, you just need to remember it. So let's just try some things out. 10 to the 3x to the 5th. So this is an AU problem. So first off, exactly the same. Exactly the same. So 10, 3x to the 5th times ln A. So ln A is going to be just ln 10. You will not have a calculator that does ln, so you're not expected to do anything like that. Times u prime, which is the prime of this, 15x to the 4th. Okay. You can't simplify that, so you just circle it. Usually that's why it's very simple. If you remember it, you just write it down. You can't simplify it typically. That's not what I wanted.
Can you do one with that use 2 of the equations?
What's up? U to the what equations?
No, I said, like, can you do a problem that uses 2 of the equations?
Sure. Like a complicated one, you're saying? Like there's multiple parts to it?
Yeah.
Okay. So let's do, I'll use the same number. 10 sine 3x to the 4th. I'll mix it up this time. 3x to the 4th. Okay. There's a cool one. So first one, a to the u is exactly the same. So that's 10 sine to the 3x to the 4th times ln a, very straightforward, ln 10, times the derivative of the exponent. Now the derivative of the exponent is, instead of sine, it's going to be cosine, 3x to the 4th, but you're not done because you need the derivative of the inside of the cosine. So that's going to be times by 12x to the 3rd. Again, nothing really could be simplified. You could circle all of that. I guess that would be a question that's a little bit more involved. And what do we got? Oh, and then let's just do a quick ln one. Ln of 12x to the 5th plus 2x to the 3rd. Something like this. So just identify what your u is, which is this inside. So your u prime should be 60x to the 4th plus 6x to the 2nd. So u prime goes on top, 60 x to the fourth plus 6x to the second over, it's ln, so nothing special. So then just the u original, which is 12x to the fifth plus 2x to the third. In this situation, you need to, what do you need to do? You need to see, what can we factor out? On the top, we could factor out x squared and a 6. On the bottom, we could factor out a 2 and an x cubed. So we could reduce that down to 3 over x times, if I took out a 6, that's 10x to the second plus 1 over, if I took out 2x to the third, 6x to the second plus 1. Yeah. You could just leave it like that. That's fine. If you want to FOIL that back out, that's fine. But I get it. So this one, since you can simplify, simplify. You might probably not have something you can simplify, but straightforward like that. Okay, I think that goes over every type of problem that could possibly be on your test. If I miss something, I'll just put a legal disclaimer. This does not necessarily cover everything on your test. Make sure to study everything you have. But yeah, I think I covered most of everything. Does anyone have any questions on this final part right here? And if not, Brianna, I'll go to the original afterwards. Jay, any questions?
No.
All right. I'm going to stop recording because I already did the recording for the first part. So